Good evening, my 12th standard warriors. Welcome to the one-shot revision session on the chapter of current electricity in the Pathfinder series with me, Shreyas, your physics master teacher at Vedantu. Hello, Nishant and everyone. Hi, Karthikeyan. Welcome aboard. So many of you were eagerly waiting for this session. So, my name is Shreyas and I'm the physics master teacher and I lead the JEE division of physics department. And I have been training kids for a very long time. And under my mentorship and guidance, I'm really proud to say that not only many students have got into IITs, NITs and other top-notch prestigious institutes of our country and beyond, but also they have secured top ranks in All India rank, like 2-digit ranks and 3-digit ranks. So glad that you are here, and my aim to be on YouTube is to make sure that you enjoy physics, you learn physics like never before, and also solve lots of problems and see the hidden tricks and tips for solving all these things. I also gain a lot of conceptual knowledge while you study with me. So welcome to the Pathfinder series. This is for the 12th standard, and if you are in 12th standard, you should definitely consider checking out the entire playlist which is there on YouTube on this channel. This channel is a special channel because this is an English medium channel. Very rare to find an English medium channel in our country because we have Hindi channels or Hindi English channels. So really glad that you could make it here. And before we go ahead, do not forget to do one small favor. Yes, go ahead, smash that like button and also hit the subscribe button. And do not forget to check out our Telegram group link where you will get all the important PDFs and the information. Hello, Karthik. Hello, good evening, Sarlina. Hello, Karthikeyan. Hello, Sankar. Thank you guys for all the love. Vanakkam, Dhanush. Hello. Okay, so I'm not sure about Kusat Kerala Bacha. And welcome aboard Gangarapu. And maybe, Karthik, we can have a special session for just the college rankings and all of that. Yep, you can just put it up in the comment section, or definitely we'll consider taking up a session on the rankings and what do these rankings mean. Thank you for your suggestion. Well, in case you have missed my previous backlog session on Gauss's law, you can check it out. It's there in the previous videos. Also, if you want to attend 11th standard backlog sessions, you are again free to do so. Also, you are free to attend even the passing out batch classes for JEE Advanced. So the one I conducted on Monday, that was the previous year questions of JEE Advanced, and today morning I conducted a session for mechanics questions, so it will be like a revision for you. Tomorrow morning I'll be coming on biotonic for the passing out students with lots of amazing questions, and similarly I'll be keeping on updating the schedule as the week progresses for the next week. Alright, so I hope you have hit the subscribe button, guys. Do not forget to do that, and yes, please shower that love by smashing that like button out there. Now remember one thing, if you want to be a ranker, if you want to be a top performer, if you want to ace JEE Mains, JEE Advanced, BITSAT, CETs, or your CBSE board or your state board, then you need proper coaching. You cannot just completely rely on YouTube. YouTube is the icing or the cherry on the cake. It will add that extra flavor so that you can take your performance to the next level. But you need a regular coaching as well, be it offline or online, you need it. Let me tell you that. And all these results that you see on the screen are of Vedantu, be it ICSE board, CBSE board, JEE Mains, and consistent improvement even from the first attempt to the third attempt, like 7.5x jump right in the Vedantu students, and it's bang on. I mean, like, all this is because of the material, the test series, and our amazing teachers, obviously combined with the hard work and the dedication of our lovely students. So if you're considering joining a coaching, or if you have not yet made up your mind, please check out the link which is there in the description box below, because there is a batch which is starting on Monday for 12th standard. Also, there is a link for joining the KVPY crash course, which you should also check out. And all these courses, you can buy it for 1 year, or you can even buy it for 1 month, or you can pay monthly installments and take up the entire course. And these courses are very affordable, like you can see, 36,000 for 12 months. If you divide it by 12, I mean, like, hardly 3,000 rupees per month. That's very dirt cheap. I mean, if you compare it with the regular coaching. So do check out the link and let's get going with our session today. So like I said, today's session is one short session on current electricity. After this session, you should definitely check out the playlist of detailed classes on current electricity, where I have solved mains plus mental all the concepts again in detail. This will definitely help you revise the entire topic today, to push yourself harder and watch the detailed classes, because you still have that time in hand. Alright, so let's get going. Hi BTS Army, hi Even, welcome Gangarapu. Yes, let's get going guys. I'm very good. Your NEET 2022, can you watch this? Definitely, because the physics part is the same. Only the type of questions will change in NEET and in JEE Mains or Advanced. Definitely you can watch it. Alright, now quickly revising. What is current? Current is nothing but, flow of charges. This whole chapter is based on current, voltages, resistances and all of that. So we have seen in electrostatics that the charges stay at rest. Electrostatic, charges at rest. This is current, which is flow of charges. So when you have a conductor and you apply a voltage difference, when I say voltage difference, that means you connect the positive and the negative terminals of a battery. And the moment there is a voltage difference, you will see that the current will start to flow from high potential to the low potential. And that current is the charge flowing per unit time. So current is nothing but rate of flow of charge. And we all know that the unit of current is ampere, and 1 ampere is how much? 1 coulomb upon 1 second. So that's 1 ampere. Now, hello Esau, welcome aboard. Now, this current will be passing through a cross section. You can see that the current is nothing but passing through a cross section. How much current is flowing per unit area? That is called as current density. You can see that. Current density is current per unit cross section through which it is cutting through. So very important. J is I by A. So the unit will be ampere per meter square. Okay, keep this in mind. By the way, if you take area on the other side, then mind it that this equation will slightly change. I mean, in the proper form, it will look like this. I is equal to J vector dot area vector. How many of you remember this? Let me know in the chat box. Actually, if you take area on the other side, it will become a dot product. Now, you might be wondering, sir, what's the direction of J and what's the direction of A? Hello Ankit, welcome aboard. What's the direction of J and A? See, J always has the direction of the current. Wherever the current is, that's where J is. A can be anywhere. A is always perpendicular to the cross section. I'll give an example. Imagine there is an area like this, and this is the conductor. The current might be flowing like this. If the current is flowing this way, J vector will also be that way. But the area vector, that area vector will be perpendicular to the surface. So this is area vector. So area vector is always perpendicular to the surface. Current is always in the direction of current density. I hope this is clear. Hello Mrunmai, welcome aboard. Venki, you are just probably 2-3 minutes late. Oh, well, Ankit, I hope your test went really well, and probably this revision will probably even brush up things in a better manner. So you can, even if you are arriving late guys, you can still go a little bit behind. Even in a live class, you can take that slider behind and you can catch up at 2x speed like that. Yep. Current is the flow of electrons or protons. So current is the flow of any charges. Okay, now in a conductor, it so happens that the electrons move. That's why the current is produced. But even if protons would have moved, current would have been produced, because at the end of the day, current is just the flow of charges. But in case of normal conductors, the electrons themselves move backwards, okay, or opposite to the direction of the conventional current. So current is always in the direction, it's in the direction of positive charges. So when I say negative charges go this way, it's as good as saying positive charges are going that way. So that's why current and electrons have opposite directions. I hope that is clear. MMM, all my blessings are with you. Okay. Now, once this is understood, understand the electrons do not move with very large speed, they move with a small speed. That speed is called as the drift velocity. The speed with which the electrons move in a conductor. So that is drift velocity, and there is a very simple formula to remember it. Remember NVIDIA, and I keep telling this again and again to my lovely students. So guys, NVIDIA is a graphics card company. So current is NVIDIA. If you remember that in a mnemonic way, it's very, very easy. I is the current, VD is the drift speed, E is the charge, A is the area, N is the number of carriers of charge. How many electrons are there in one unit volume? Each material will have different number of electrons. Like copper might have more electrons. Maybe aluminum, which is a little bit bad conductor as compared to copper, might have less electrons per unit volume. So this N depends on material, and that will be given to you. I hope this is clear. Okay. Yep. Thank you, Ankit. Glad you liked the advanced session, and I would definitely recommend all the 12th standard to even attend the passing out batches advanced sessions conducted on this channel. Do electrons change path due to drift velocity? Well, here is the thing. Understand one simple logic. When electrons move, they do not move in straight line path. They might move like this. Okay, they might move like this. This is the actual way in which electrons move. But on an average, you will see that these electrons are slowly drifting apart. So you can see slowly they are moving here. That average velocity by which they drift is called as the drift velocity. So the electron's motion is random and slowly it keeps on shifting. That rate at which it shifts is actually called as the drift velocity. I hope that makes sense. And you should know this standard value. Electron charge is 1.6 into 10 to the power minus 19 coulomb. Okay. All right. Cool. Let's get moving to the next one. Okay. Now, when we talk about resistance, resistance is nothing but, the opposition to the flow of current. It's opposition to the flow of current. So this diagram is like self-explanatory. So resistor is opposing the flow of these people through this pipe. So the people are like electrons or charges, and there is some potential difference. Maybe this is on the top of a hill, this is at the bottom of a hill. So there is potential difference, and this flow will be blocked by resistance. So that's what resistance is all about. Now this resistance completely depends on the material, as in whether it is made of copper, whether it is made of some other material, maybe iron, maybe steel. Every material will have different resistance. Now the ones which have less resistance are called good conductors. The ones which have very large resistance, they are called as bad conductors. And the formula for resistance is rho L by A. That means if you take any material, okay, it will have certain length, it will have certain area. The resistance, by the way, the symbol for that, everybody knows, this is the symbol for resistance. That conductor's resistance depends on the length. More the length, more the resistance. More the area, less the resistance. It's inversely proportional. And this rho is called as the resistivity. What is it called? Resistivity. So resistivity, it's a property of the material. If I take iron, okay, no matter how big that iron piece is, resistivity is a standard property. It's like coefficient of friction, or it's like density. Like density depends on which compound or which element or which material you are talking about. Density of wood is different from density of water, is different from density of aluminium. Same way, resistivity is a property of material. Yes, very good. Now this resistivity also depends on temperature. Yes, or the resistance also depends on temperature by this formula. So when you change the temperature, when you change the temperature, hi Darun, welcome aboard. Yes, Sai Shruti, excellente. So when you change the temperature, resistance changes. In fact, when you increase the temperature, what happens is the molecules, the atoms start shaking vigorously, and therefore, the electron which is moving will now be encountered by that shaking molecule more frequently. So there is a greater chance of collision of the electrons with the molecules and the atoms, so that reduces the chances of it to flow freely. So more the temperature, more the kinetic energy of the molecules, more the chances of collision, and more obstacles, and therefore lesser conductivity, and that's why the resistance increases. Does that make sense? So that's why change in the resistance is proportional to temperature change. More temperature change, more the change in the resistance. What is R0? R0 is the initial resistance. Hi Vaibhav Mane, welcome aboard. What is alpha? Alpha is again dependent on the material. Coefficient of thermal resistance. Very important. Imagine if somebody has a big value of alpha. Some material has large value of alpha. It means if alpha is large, that means the temperature change will cause a lot of change in the resistance. So when alpha is large, when you change the temperature, delta R will change significantly. That means it is very sensitive to temperature. Is that clear? Everyone? Everyone? Alright. Now, is alpha always positive? Well, there are some materials which exhibit exactly reverse category. So when you increase the temperature, in fact, the resistance decreases. Exactly reverse. So when you increase temperature, resistance becomes negative or decreases. Delta R becomes negative. So those devices where, when you increase the temperature, resistance decreases, they are actually semiconductors. Yeah, you will learn that separately towards the end of 12th standard. But you should know that there are devices which have negative value of alpha, but conductors in general will have positive value of alpha. Keep this in mind. Alright, let's get moving. I hope everybody is clear. Thank you, Sai Shruti. Very good, Swarlina. Excellent, Vaibhav. So, the last part before we go to the problems. We are going to come to problems now. Yeah, the last theory slide which we are revising is Ohm's Law. Now, if you take any device, and you apply some voltage across it, V volts, this V volts, this is 0 volts, V volts, voltage difference is V. Then there will be some current flowing through it. That current, when plotted with voltage, will be a straight line. So here you can see voltage is directly proportional to current, and that constant of proportionality is nothing but resistance. Now, this kind of straight line graphs is only true for ohmic devices. This is only true for ohmic devices where voltage is proportional to current. So there are certain devices which do not behave or exhibit this proportional behavior. You might see probably things like this, or maybe some other graph. So this is non-ohmic devices, and you will study more about it in the later on chapters. Like semiconductors are a very good example of non-ohmic behavior. The resistance changes dynamically. Diodes or transistors or semiconductors, they have very different characteristics. I hope this is clear. Okay, Mandari, everybody is waiting for JEE Mains result. Nobody knows, bacha. Okay, I am not NTA. I wish I knew. Hello, Raji Pratap Jadhav. Welcome aboard. Arav, this session started at 7 o'clock, so I'm guessing till 8:30 at least, or 8:45 maybe. Yeah, so that's what it is. Now, just like V is equal to IR, there is an equivalent relationship. Instead of voltage, you write voltage per unit length. Volts per meter. What is volts per meter? Electric field. I hope you remember unit wise. Voltage per meter is electric field. So you have electric field. Instead of current, you make it current per unit area. What is current per unit area? It's current density. And instead of resistance, you make it per unit volume, per unit length and all of that. And then you will get it as resistivity. That's a material property. So this is a very important formula where there have been questions even in JEE Mains where J was given or resistivity was given, and they asked what is the electric field. People got confused. How do I find electric field inside a conductor? And look at this. This is very surprising. I mean, in electrostatics chapter, we have studied inside a conductor the field is 0. But over here, you are finding the value of the field. Like, sir, what the hell is happening? Guys, remember, in electrostatics, the charges were at rest. That's why the electric field inside a conductor was 0. But in a conductor, the moment the charges move, that means there must be some electric field. So you can find that electric field only in moving charges, or basically when there is current. So when there is current, when there is J, there will be electric field, else there will be no electric field. I hope that makes sense. Also, sometimes they can ask you a term called as mobility, how mobile they are. So for a given electric field, how much is the speed of the electrons? How much is the speed of the electrons? So more mobile, more the speed. The electrons are happy, they are moving with very high speeds. So that's greater mobility. You need very less field to achieve that speed. That means you have greater mobility. So mobility mu is Vd divided by E. I hope that makes sense. All right. Thank you, Black Horse. All right. Oh my God, Zeppin saying they asked a direct question using mobility concept. So straightforward formula, drift speed by E. Remember what is the formula for drift speed? Drift speed, I'll just go back in case you forgot. It's given by I is equal to NVIDIA. That's all. Akash, I'm from NIT Nagpur. Okay, so that's what it is. So quick revision done for these few concepts. Again, we'll come to some more concepts, problems, and that's how this lecture of one shot will go. Remember guys, those of you who are joining in late, you can definitely check out the part which you have missed. Also, there are detailed classes, around 6 to 7 classes which I have conducted on current electricity in this channel. Okay, there is a playlist called as Pathfinder. There are many playlists chapter wise. Check out the chapter wise playlist. I hope everybody knows how to check out playlists on YouTube. I'm pretty sure you know that. Okay, so let's try solving this question. There are two wires of the same material but of different diameters, and they carry the same current. Now the ratio of the diameters is 2:1. Then the corresponding ratio of their drift velocities. Interesting. Yeah, Gauri Shankar, usually my classes are at 7:30. I know. I have started at 7 because I am guessing the classes might be extended little bit beyond 1.5 hours. So in order to avoid the clash, that's why I've started, yeah, little bit early. Yes. Okay, come on, let's try solving this question. Okay, NVIDIA. Yes, Sai Shruti and yourself. Hello, Pratik Gaonkar, welcome aboard. So two wires of the same material. Now think about it. When the material is same, it means number of free charges per unit volume is same. And what's the formula for drift velocity? I just told you. I is equal to N drift velocity into E into A. Now, out of these terms, N is same, E is a constant, 1.6 10 to the power minus 19, and it is also given that they carry the same current. Oh, that means even I is same. That means only drift and area are variables. So it's easily seen drift speed is inversely proportional to area. Makes sense? Now the only thing is area is dependent on the diameter or radius by pi r square. Area is pi r square, right? So therefore, since this area is nothing but pi r square, drift speed is inversely proportional to r square. Therefore, drift speed 1 upon drift speed 2 will be r2 by r1. Order has changed, square. I hope that makes sense. Okay, so that's what it is. So r2 by r1. Diameter is in the ratio of 2:1. So this is 2, this is 1. Okay, square, that means it is 1 by 4, and 1 by 4 is option D, I suppose. Excellent. Many of you got it correct. Hi Naveen, hi Sai Shruti, very good. Very good Bhaskar. Excellent Swarlina. Very good Shilpi. Hello Chiveshwara Robox. So guys, all those new warriors joining in today's session, welcome aboard to the special exclusive JEE English channel. And we have started this Pathfinder series quite some time back, and these are the revision sessions. So Pathfinder series is for all the 12th standard students. It's a long-term batch for free on YouTube. So we started with electrostatics. Now we have almost reached, we have completed in fact electromagnetic induction recently. After this brief revision, I will do the next chapter, which is alternating current. So you should definitely consider subscribing and hitting that subscribe button and also smashing that like button so that YouTube is more likely to recommend you this channel on daily basis. Okay, option D is correct. Next question coming up on your screen. In a region 10 to the power minus 19 alpha particles, 10 to the power minus 19 protons move to the left. 10 to the power 19 electrons move to the right. What is the current? Interesting question. Let's see how many of you can get this. Pratik? Yes, bacha. Obviously, you will find it difficult if you have not studied physics properly. Usually, when students move from 10 to 11th, if they have not joined a proper coaching, that difficulty continues till 12th standard. So my advice is start following my lectures and start learning physics the right way. Also, there is a link for joining our pro subscription. You can also take up my courses free of cost again once you are in the pro membership. Also, let me tell you, you need to question and think and try to solve questions on your own without looking at the answers. And when you put in that faith and that hard work, trust me, you will do it. All right, let's move on to this question. So alpha particles moving left side, protons also moving left side, electrons moving right side. Electron is negative, proton is 1 positive, alpha is 2 positive. Isn't electron moving to the right equivalent to this? I can forget it. It's as good as saying another positive charge moving towards the left. It's one and the same thing. Isn't that right? So don't subtract. They are not cancelling. Positive moving left and negative moving right, they will not cancel. In fact, negative, had it been moving towards the left, then that positive and negative would have cancelled. Here, in fact, it will add. So the current, which is total charge by total time, will be alpha particle has 2e charge. 2e charge. But how many charges are there? How many charges are there? Alpha particles 10 to the power 19 per second. So into 10 to the power 19 plus protons has a charge of E. How many particles? Well, 10 to the power 19 per second. So per second is already taken into account, so don't have to divide by time again. Plus another electron, so that is E into again 10 to the power 19. So this is going to become 2E plus E plus E. That's going to be 4E. So 4E into 10 to the power 19. So this will be 4 into electron charge is 1.6 into 10 to the power minus 19 into 10 to the power 19. These two cancel off. So 16 fours are 64. So this will be 6.4 amperes, but that's towards the left side. Yep. So towards the left, a lot of you were saying B. The answer is C. Hello Arnav, welcome aboard. Very good Fatima, very good Mohammed. Alright Krishna Bacha, don't spam. Very good. Some of you got it wrong, some of you got it correct. I hope you understood what mistake you made. So electron moving to the right is the same as a positive charge moving towards the left. Vaishnavi, join in Bacha. Whichever part you missed. Mohammed, also good evening. Whichever part you missed, just watch the replay later on. Continue the session from here. I'm pretty sure you will get it. Okay, but in case you don't, watch the replay of the missed part. Alright, let's see the next question. The temperature coefficient of resistance of a wire is this much degrees per degree centigrade. Okay, at 300 Kelvin, okay, the resistance is 1 ohm. Now, at what temperature do you think the resistance will become 2 ohm? Very good, Sashretri. It's clear. Chalo, come on, my warriors, figure this out. At what temperature do you think the resistance will become 2 ohm? Let's try and do this question. All right. So which formula do I use? I think I need to use the formula of del R is equal to initial resistance into alpha into delta T. Most likely this will help me. Has the resistance changed? Yes. How? Look at this. Earlier it was 1 ohm, later on it becomes 2 ohm. So the change in the resistance is 2 minus 1. Okay. Do I know the initial resistance? Well, yes, the initial resistance is 1. Okay. Do I know the value of alpha? Yes, I think I know it. So it is 1.25 into 10 to the power minus 3. Okay, that's also given. Next, delta T is the only unknown. So I think I can now find out the value of delta T. 2 minus 1, 1. So this will just go down. So this will become 1.25, and when you take it on the other side, it will become 10 to the power 3. So this I can write it as 10 by 1.25 into 100. This will be 8. Yeah, 1.25 goes 8 times with 10, because 1.25 into 2 is 2.5, 2.5 into 4 is 10. So this will be 8 times, so 800. So this will be 800 Kelvin. Well, very good. So just what is the temperature difference? That will be final temperature minus initial temperature, which is 300. It's nothing but 800. So naturally, final temperature is 1100 Kelvin. Okay, that's option D. Very good. Many of you were correct. Very good. Proud of you. Proud of you, Shilpi, Vaishnavi, Vaibhav, Swarlina. Excellente, Sajruti. Excellente. So if alpha in the variable, then can we do it by integration? Yes, Ankit, you have to use integration in case in the let's say charge was a function of time. If let's say charge was some function of time, then the current, okay, will be not integration in this from charge to current, you have to use derivative. So it will be d by dt of that function of that time. That's how you do it. Okay, cool. Let's get moving to the next question. All right. Okay. So yes, the correct answer was D. Correcto. Beautiful. Next question coming up on your screen right now. Okay. Interesting. There is current versus voltage graph, and it is given for the same wire but for two different temperatures. This is for T1, this is for T2. Based on the graph's nature, you have to comment on which temperature is more or which temperature is less, or maybe they are equal, or maybe there is some other relationship. Come on, figure this out. It's not that difficult. What do you think is the relationship between the temperature of this material? If it is mentioned, these are the current versus voltage graphs. Look at the slopes, think about Ohm's law, probably you will get it. All right. Some of you are saying it's A. Okay. Venki saying A, Manoj also saying A, Karthikeyan also saying A. All right, Mohammed, Vaibhav, everyone. Okay, let's try to figure this out. See, in this case, it's nothing but if I write V is equal to IR, which is Ohm's law, just write it in a slightly different manner. Current is Y, voltage is X. So I by V will be 1 by R. Now what is I by V? It is nothing but slope of I versus voltage. Now think carefully. In this particular scenario, the one which has more slope, okay, the one which has more slope will have less resistance. Makes sense, guys? The one which has more slope will have less resistance, and the one which has less resistance will also have less temperature. So who has less temperature? T2. So T2 is less than T1. I hope that makes sense. No, it is not B, it is A only. Correct, it was A. T2 is less. So the one which has more slope, who has more slope? T2. So the one which has more slope has less resistance. So the one which has less resistance will also have less temperature. So T2 is less than T1. So which is option A. As simple as that, based on Ohm's law and thermal resistance. Interesting. Very good. Many of you got it. So don't get confused. It's okay. OJS, no, it is A only. All right, cool. Let's move on to the next question coming up on your screen. There is a copper wire of certain length and certain radius, and they are joined in series with another wire of some another length and different radius. And now the current passes through the wires which are in series. What is the current density ratio in copper and in the iron wire? Very interesting question. Let's see if we can solve this. So you have a copper wire over here of radius 1 millimeter and length 1 meter, and then you have an iron wire of 3 millimeters radius and length is 2 meters. Okay, so this is iron. So the length was 1 meter and this was 2 meters. This radius, here the radius was 1 millimeter and here the radius is 3 millimeters. So that's the diagram. Probably it should help you a little bit. That's your hint. Come on, my warriors. Yes, the live started, Rajvi, at 7 o'clock because I was skeptical whether my lecture will end before 9 o'clock. So that's why I started early, so that there is some buffer time if there is a lecture at 9 o'clock, right? Cool. So that's why, guys, it's very important you join the Telegram group. I hope you know you can join the Telegram group link. There is a link in the description box below. In that Telegram group, I regularly announce when my lecture is, in case there are changes or the schedule, the entire PDF or any other important information, news update, all those are given in real time on our Telegram group. So please do not forget to join the Telegram channel of Enthuse. And yes, if you have forgotten to smash the like button, please do it right now and also hit the subscribe button. Okay, let's get going. Now, what you should understand in this problem is that the current flowing in both of them will be same. So the current is same because they are in series. That's what happened. The same current will flow. So if the current is same, so that's it. Think about it. Current and current density, how are they related? J is nothing but I by A and area is nothing but pi r square. So hence J1 by J2 will be R2 by R1 whole square. Because current is same, pi is a constant, J is inversely related to R square. So J1 R1 square, J2 R2 square, both are opposite. Now it's simple. What is R2? R2 is 3. What is R1? That is 1 whole square. So that would be 9:1. So where is 9:1? Yes, that's option C over here. Yes, a lot of you got C. Very good, very good, excellent. Proud of you, my bacha log. Oh, no problem, Lakshana. Happens sometimes. Probably you can do one thing. You can mute all the other channels. Telegram has that option, and you can probably just notify only our channel. There is also one more thing you can do in case you want to get notified. So when you right now, probably it will not be shown over here, but in general what happens is you probably get some bell icon over here. Right now I'm in the Enthuse account, so it is not shown, but you can check that bell icon, hit the bell icon over there so that you will get notification just when the live is about to start. Okay, hello Asha, welcome aboard. Okay, so that's 9:1, that's done. Now let's go to some circuit related problems. Okay, hello knowledge facts, where first let's quickly revise resistors in series. When resistors are in series, then what happens is the current which flows through them is same current will flow, but the voltage across this obviously will be different. In fact, the voltage across R1 will be I R1, voltage across 2 will be I R2. So it depends on the resistance, like you can see, and the current is same. The effective resistance is just R1 plus R2 plus R3. So you can replace these three with one single resistance, and there is a direct formula which is called as the potential divider formula, which is very helpful at times. Imagine a question like this, where for example this is 100 volts, okay, and this is, let's say, 0 volts, and R1, R2, R3 are given, and then they ask you what's the voltage between these 2 points, or between across the ends of resistance 2. It's nothing but R2, okay, R2 divided by total resistance into V. That's it. So that resistance divided by total resistance and the whole thing into the total voltage difference, which is 100. So if they ask you what is V1, voltage across R1, it will be R1 divided by total into V. So this becomes very, very useful formula. So this is called as the potential divider formula. I hope that is clear. Surikirtan Nayal, you can just replay it again. Okay. So current is same, and using Ohm's law, V will be I into R. V will be I into R. So every resistance will have different voltages. Equivalent is R1 plus R2 plus R3, and voltage across any one resistance is just given by this potential divider formula. The potentials get divided, and this is the formula. That resistance upon total into total voltage. That's something which should be there. Okay, Vingesh, alternating current probably next week. Okay, give us some time. Already I have mentioned this regularly in my sessions that I am right now conducting, revision classes of all the things which are done. So only one chapter is remaining from 12th standard for term 1. I hope you know that. Yeah, so only one chapter, and that is AC circuits. So after that our term 1 syllabus is done, and you are fully prepared for CBSE term 1 examinations. So that would be really cool, guys. So it's very good time now to revise. When you have resistors in parallel, the current will distribute. You will see that the current will distribute itself, and you will see here there will be current like I1, I2 and I3, and this current will be I1 plus I2 plus I3, the total current. Now the one resistance which has less resistance will have more current, okay, and the one which has big resistance will have less current. So that's why I have said current is inversely proportional to resistance when in parallel. Okay, the current is different. What will be same across all of them? Voltage. All resistors will have same voltage, and the equivalent resistance will be 1 by R1 plus 1 by R2 plus 1 by R3 will be 1 by the equivalent resistance. Yes, Vishnu, electrostatics chapter is completed already. In fact, the revision was also done just last week. In fact, just few days back I completed Gauss's law also revision. So you can check it out, the entire chapter. There are two playlists, electrostatics and Gauss law separate. There are easily some 10 lectures or more. You can check out all the lectures, all the concepts in detail mentioned in those sessions. Now, important thing to know is when you solve resistance problems, there are many ways of solving to to find out the equivalent resistance. Like, in 10th standard, you just know if they are in series and parallel, how to combine them and find the equivalent. But there can be many more complicated circuits, and one such thing is Wheatstone arrangement. A Wheatstone arrangement will have usually at least 4 resistances and maybe one resistance or any other device looking somewhat like this. The current will come from outside, will get split, and again it will combine over here and it will come back. Now this branch, which is the device wala branch, will be rendered useless. That means you can completely get rid of this device and there will be no current flowing in it only when R1 by R2 is R3 by R4. This special ratio should be mentioned. The special ratio should be mentioned. Okay, yes, very, very important. And this particular arrangement, when this ratio is obeyed, this is called as balanced Wheatstone. Okay, this is called as balanced Wheatstone bridge. If it is not equal, then it is called as unbalanced Wheatstone. So usually you will have problems on balanced Wheatstone, but in case there is an unbalanced Wheatstone, how to solve that? I have discussed that in detail in my Pathfinder session of current electricity, again there in the playlist. Do check it out. Okay, now having said that, when this is balanced, you can completely ignore this. Now these two become in series because there is no current, and these two also become in series and their combination is in parallel. So it becomes a very simple circuit, like you can see. Yep, I hope this is clear. The path of a free electron will be almost straight, bacha, ignoring any other intermolecular or forces acting on the electron. Okay, now I'm hoping that it is not breaking. Oh, is it? It's breaking in between. I'm not sure why it's breaking. Okay, okay, cool. Maybe it's giving me a hint that the battery is getting low. Maybe for the next class I need to change the battery. All right, next thing, disguised form, infinite form, or any other symmetry form. Standard forms which you should know. Okay, first of all, disguised form. In disguised form, what happens is, it is actually a simple circuit, but you do not know it is a simple circuit unless and until you visualize, imagine and reorient the circuit. Yes, you reorient the circuit. Example, this one. This might look like a complex circuit, but actually it is simple. How do you know that? Look at this. There is a wire between B and C. So both the points have same potential. So in fact, start by marking potentials and you will see point B and point C have same potential. Also point D, okay, point D and point A have the same potential, and this point M has a completely different potential. So you know what I can do? I can redraw this circuit. How? Look at this. This is point B. Okay, this is point B. Okay, from B I have two resistors. You can see from B I have two resistors. Okay, one goes and meets at M. Okay, one goes and meets at M, and the other one also comes and meets at M only. Okay, so both these resistances are done. One more resistance is there, but that resistance goes and meets at A. Achha, so I will draw one more resistance like this, and that goes and meets at A. All right, that goes and meets at A. And between A and M, there is one more resistor. That's it. Now this is the equivalent circuit of this one. This is the equivalent circuit. Okay, so I don't have rough idea, Rushin, but it should be out. But there is, you know, that ghotala going on because of that scam. So that's why it is probably taking a little bit more than expected. But don't worry about it. Concentrate on JEE Advanced or your local CETs. Now you can see these both are in parallel, and this along with this is in series, and this whole thing is in parallel with this. So it becomes a simple series parallel circuit. This was a disguised form. So you have uncovered the mask and you have converted it into a simpler circuit. That's what you can do. Very good. Okay, great. Okay, when are my live micro courses starting? Rajat, in just a matter of week or two. Just give me some time. Okay, it's just around the corner. I'll announce the exact dates, okay, very soon for 12th standard. All right. Now, the next thing that you should remember is when resistors are in infinite form, you will see a repeating pattern. You can see this pattern is getting repeated again. So once you see a repeating pattern, okay, understand the resistance between these 2 points, let's say I will call these points X and Y, will be same as the resistance between these 2 points X1 and Y1, correct? Because if I hide this, this is the same thing again till infinity. So how about replacing this entire thing with the equivalent resistance? So when you do that, what happens is, you know, you have this resistance, okay, R, and you have this resistance, which is also R, and this entire thing has been replaced by an equivalent resistance. This is R equivalent. That's it. This entire thing between X1 and Y1, in case you want to know the points, I'll again mark it over here. This is X1 and this is Y1. And remember one thing, their equivalent, okay, their equivalent will also come out to be, the equivalent between these will also come out to be R equivalent. So now you see this is series, these two are in parallel, and that is in series with this R. Their combination again gives you R equivalent. Solving it, you will get R equivalent. I hope this is clear. This is how you solve when multiple resistors are in parallel. Okay, find the repeating pattern, ignore the first pattern, you will see the remaining pattern has the same resistance. just write it in the smaller or modified shorthand form, and now solve it like a normal series parallel circuit. The equivalent of that should again give you R equivalent. That's it. Most likely it will be a quadratic equation. Okay, I hope you remember, most of the times this is a quadratic equation. Last thing, these kind of problems, wherever you have symmetry, okay, wherever you have symmetry, what do I mean by symmetry? What you should do is first find out the points between which you want to find the resistance. Let's say it is A and B. So just draw a line between A and B. Okay, just draw a line between A and B. Now draw a perpendicular bisector. This is the perpendicular bisector. So this is your perpendicular bisector to the line joining the points across which you want to find the resistance. If you find same things left and right, if you find the same things left and right, then you can do one small thing. You can ignore whatever is there on the line of symmetry. What can you do? You can completely ignore whatever is there on the line of symmetry. That's the funny part. So you can completely get rid of this 4 ohm and this 4 ohm because this is the line of symmetry. That's the trick which you should use. Okay. Why ignoring the first pattern? No, there was no pattern over here. This was the repeating pattern. Okay. If you are talking about the I'm just think of it this way, guys. I mean, I'm pretty sure for the last problem I'm talking about, you would have solved these kind of problems. Root of 7 plus root of 7 plus root of 7. What do? You just write it as root of 7. You assume this as x. And this part, you assume it as x. So x is root of 7 plus x. And now you solve it by quadratic. Is that ringing a bell, Venki, in your head? So this problem is very similar to this problem. Nothing else. Okay, I'm pretty sure you would have solved this kind of problem in maths, especially in quadratic expression. Now, once you hi Hridaya, welcome aboard. Once you ignore these two resistances, then it becomes a much simpler problem like this. Okay, so it becomes probably something like this, and yeah, over here like this, and over here like this, over here like this, and over here probably like this, and over here probably like this, and maybe like this, and maybe like this. Now this is a simple problem. You can see that these two are in series, these two are in series, these both are in parallel, and now you have 1, 2 and 3 branches in parallel. Now you can solve it. Okay, now you'll be able to solve it because now it is a very simple circuit. 1 branch, 2 branch, 3rd branch. So 3 branches in parallel. Now you can just solve it. I hope that makes sense. So that's how you solve problems on symmetry. Always draw the line between the 2 points where you want to find the resistance, draw perpendicular bisector, ignore all those objects, you know, on the perpendicular bisector if left and right is equal. That's it. So Srishant, if you have a backlog of RC circuit, just do it. It's very simple. Just watch my lecture. How much time will it take? 2 hours max. Okay, you have 2 hours, right? Don't tell me you don't have 2 hours. Okay, because your exam is next year, bacha. So guys, backlog is just, you know, your perception. Actually, you don't have backlog. You just have to find that time to cover up, you know, the missed part. Okay, you can cover it. So I have given some pointers over here. Whatever I told you in a proper sheet, you can download it from our Telegram group. Okay, let's go ahead. Okay, let's try and do some questions based on equivalent resistance. Okay, what will be the equivalent between AC circuits? Will be doing it, bacha, next week or so. Okay, and then you can see how do we find equivalent of AC circuits using phasor diagrams. The resistance of the following circuit between A and B. Let's see who is really quick to solve this question within 1 minute, and I have started the countdown timer right now. Let's see if you can do this. Come on, my warriors. Hi, Shruti, come on. Yes. All right, Venki. Come on, my warriors. Figure this out. What will be the equivalent between A and B? It's not a difficult question. Priya, I chose mechanical engineering. Knowledge facts saying A. Let's see. I don't know. All right, somebody saying D, somebody saying C, somebody saying A. Very good, very good. Let's see. Good evening, Sai Telugu. Long time and very late for the class also. Alright, the bell has rung and time to solve this question. First of all, this is a balanced Wheatstone bridge. You can see that. This is balanced Wheatstone. If it's a balanced Wheatstone bridge, then you can completely get rid of this. Why is it balanced? 2:2, 2:2. You can completely ignore that. So now it becomes a simple circuit. Now you can also see this 2 and this 2 are in series, so it will become 4 ohm. This 2 and this 2 are also in series, so that will become 4 ohm. Now let's redraw the circuit. So you have A over here, you have one more resistance 2 ohm. Now 4 and 4, they are in parallel. So equivalent, this 4 and this 4, they are in parallel. So 4 and 4 in parallel, that will become 2 ohm again, and we have one more 2 ohm here, and do not forget that 2 ohm below. So that's how it is. This is A and B. Now you can see that these two 2s together will become 6 ohm, and there is one 2 ohm here. This 2 ohm and this 6 ohm are in parallel. So RAB, so using the parallel formula, what will you get? 2 into 6 divided by 2 plus 6. This is 12 by 8, which is 4 if you cut it, it will become 3 by 2. So 3 by 2 ohm, which is option A. Yep. Some of you might have forgotten 2 ohm below. Do not forget that. So these are two parallel branches. So from A, the current goes, it splits and again comes over here and comes outside. So be careful. This 2 ohm also has to be considered. Yep. How do you solve unbalanced Wheatstone's bridge? Perfect question, Samarpit. So, you know what you need to do? Just check this lecture out. Okay, I have conducted a detailed explanation. If you go to the playlist out here, okay, so just go to the playlist, go below in JEE Physics. Okay, go below and you can see current electricity, 8 lectures. My God, you guys must be lucky. Okay, just pause this ad, go below. And you can see over here Wheatstone's meter bridge, current galvanometer, current electricity, potentiometer, advanced questions. So check out the advanced questions. Also check out KCL and KVL. In these 2 lectures, I might have done these kind of questions. Okay. So that's all you need to do, Samarpit. I hope this is clear. So check out KVL and KCL related lecture and also check advanced. In one of them, I have definitely done it. All right. Let's get moving to the next one. Okay, cool. Yes, the answer is 3 by 2 ohm. Next question coming up on your screen, and this is it. So the question says, what is the resistance between, oh my God, this was not supposed to be R and Q, it was supposed to be P and Q. Okay, so this is supposed to be P, right? Okay, not R. So between P and Q, that's the question. So what's the resistance between P and Q? Let's see how many of you can get this. I'll give you a hint. This is a question on disguised form. Maybe you're not seeing that disguise. Just uncover the mask and you will see it's actually not that difficult. Hello Prudvi, welcome aboard. Hi Faiz. All right Adarsh, come on, my warriors, figure this out. How are you going to do this? I feel you can you please cover full JEE syllabus? So they have already completed term 1 syllabus, okay? So in the remaining months, obviously the syllabus will be over. So I mean, 4 months is too large. Even much before that, the syllabus will be over. Okay, don't worry. All right, chalo. But it's not about just me doing the syllabus. You have to also practice, Sukhdev. All right, option A says Divesh. I'll tell you what. This point, same potential. this point, this point, this point, same potential. This point, same potential. Now let's draw the circuit again. So from P, okay, I will see that this resistor and this resistor are actually in parallel because same voltage difference. So how about showing it like this? So this is P, okay, I will show it probably like this, okay, and now this is nothing but point Q. These two resistors are exactly these two resistors. Now these two resistors are also in parallel because voltage difference across this and this is same. Cross circle, cross circle. So I can also write it probably like this, and I can just show another resistor here. And from this point, again these two resistors are having same voltage difference, so they are again in parallel. So just put these two like this. Now that is the equivalent circuit. So that has been uncovered, the disguise has been removed. Now you can clearly see these both are in parallel, so it will be R by 2. These both are in parallel, R and R will become R by 2. These both in parallel, so it will become again R by 2. Now you can see this R by 2 and this R by 2. Alright, this entire stretch over here, they both are in series. So in series, what will happen? R by 2 plus R by 2 will become R. Now this R by 2 and this R, one branch on the top, one branch below, they are in parallel. So hence what you will see is RPQ will be R into R by 2 upon R plus R by 2. So that's going to be R by 2, one R will go off, 1 plus 1 by 2 is 3 by 2, so it will be R by 3. That's the answer. Where is R by 3? Option A. Let's see how many of you have given it. So Srinath, if I'm not able to redraw the circuit, what you should do is first mark these points. That's what I have done. Once you mark these points, check which ones are in parallel, which ones are in series. Second step. Third step, start from a point and then slowly start making the circuit in easy way. Just do that. With little bit of practice, you will be able to do it. And let me tell you, this book has lot of questions like that. Which is this book? Tattva book. Tattva book. This is given by Vedantu. If you want to solve only problems on this, there are only problems on those kind of circuits over here. Parallel you want, yes, it's there. Infinite resistance you want, yes, that is also there. If you want symmetry method problems, that is also there. So every concept there are problems for you to practice and solve examples as well. This also has previous year questions, advanced questions, mains questions, everything. Plus you can also check out the PDF from my previous sessions in the playlist. Okay, cool. So that's why the answer is R by 3. Let's move ahead to the next question. Okay, what is the total current supplied by the circuit in this case? Let's see how many of you can do this. Very good, Divesh. All right, you are first. Jai Jinki, a long time. Okay. Samarpit, I won't send the PDF. It is automatically uploaded. Okay, I don't have to do anything. It gets uploaded by our content team. So you need to just join the Telegram link. Okay, so it will take 1 day. Okay. Thank you, Divesh. Okay. Please say a tricky way. The trick, I'll tell you, Rajvi, is nothing but question each and every line, whatever you read. Never ever accept anything which is given in the book so easily. Think, try on your own and spend time while solving problems. Just don't go to the next problem without doing analysis of what exactly has happened in the problem. That's the only trick. If some other teacher has told you that no, there is a trick, just learn these shortcut formulas and that's it, your job is done, your life is smooth and you can chill out and vacation in some probably nice place like Goa. No, that's not going to happen. Okay, you have to do it this way. There's no other way. Feel the subject. Try to understand what is happening. Get a feeling out of it. Try to relate physics laws with maths. When you find the perfect combo of physics and maths, when you feel and you are able to frame those equations, that's when you will be able to love the subject and solve many problems. Okay, so let's try and solve this question. A lot of you are saying D. Okay. Yes, Sukhdev, even if you complete it by December, it is okay, bacha. Alright. Now let's do this question. What you need to do over here, again I think it is disguised form. Yep, trust me, this is again disguised form. Let's try and do this question. First of all, see, if I mark this point as a dot, this is also a dot, this is also a dot. Okay, if I mark this point as a circle, same potential, this is also a circle. If I make this as a box, why box? Because there is no wire, the potentials will be different. Now try to draw the circuit. How? Start from any point, let's say this dot. Okay, let's say I start from that point. First I will draw the battery. Okay, 6 volts battery. So where did I start from? I started from that dot, and then I have gone through the circle. Now what do I get? There are 2 circles, you can see there is a wire. I can combine both of them together because I can show this resistor and this resistor, 2 and 6, coming out from the same point rather than 2 separate points. It makes more sense. So how about showing one resistance and another resistance like this coming out from here. So this is 2 ohm and this is 6 ohm. Okay, this is both connected to the circle. Where do they both meet? They both meet at that box. All right, so that is that box which I am showing it over here. Hold on, there is one more resistor which is coming out, but it is not ending at the box. You can see that the 3 ohm resistor is also there. Oh, so there is one more resistor which is 3 ohm resistor, but where is it ending? Oh, it is ending at the dot. Achha. So I can just draw one resistor like this and it ends at the dot. So this is 3 ohm resistor. Make sense? Lastly, between this box and this dot, there is one more resistor. What is that resistor? That is that 1.5 ohm resistor. That's it. Now this becomes such an easy circuit to solve, isn't it? Isn't this now an easy circuit to solve? Think about it. Oh my god, somebody was half an hour late. Great, be regular guys. Yes, now it is easy. 6 and 2 ohm in parallel. 6 into 2 upon 6 plus 2, which is 12 by 8, which is 1.5 ohm. 1.5 and 1.5, think about it. So what will happen? This battery of 6 volts that has, one 3 ohm resistor here. Okay, it has one 3 ohm resistor like this, and on the other side it has that 1.5 and 1.5 also coming like this. So 1.5 plus 1.5, which is also 3 ohm. Now this 3 ohm and this 3 ohm, you can clearly see both of them are in parallel. That means it will be 1.5 ohm. Now the last part, the current, that current will be voltage divided by resistance, which is 4 amperes, which is option C, guys. How many of you got this? Wow, beautiful. Sai Telugu, excellent. Knowledge facts, very good. Sai Shruti, excellent. Zayed, very good. Mir Waris, very good Jiva, excellent. I can see so many people. All right, very good, excellent. How current is different? I mean, I'm not sure, Sai Charan, which current you are talking about, but yeah. So that was a very simple circuit if you mark the points carefully. That's it. Glad you liked it. All right. Okay. So whichever part you did not understand, probably Sai Charan, you joined in a little bit late. I started this point sometime back. Just go back to that point and start from beginning. You will get it. All right. Start it from there. You will definitely get it. Okay. Chalo. Let's get moving to the next thing. But before that, remember all the problems, whichever you want, are there in this booklet of Tattva. Now let's move on to Kirchhoff's current law. How they are in series? Which one is in series? Okay, see guys, this 2 and this 6 together, this 2 and this 6 together just gave me 1.5 ohm. And there was one more 3 ohm from outside, and their combination was over here. This was 1.5 ohm. And these together over here was connected to this battery. Now don't you see this 1.5 and this 1.5 are one after the other? So what are they in series, right? So they are in series. So 1.5 and 1.5. So that's why it became 3. And 3 and 3 parallel. Parallel means again make it half. That's it. Yep. Okay. Can you solve this problem in 5 seconds? Yes, knowledge facts. You can definitely solve the problem in 5 seconds if you know the answer beforehand. Or else you will take more than that. Okay. Joshua, you need my honest opinion. I have started studying seriously 1 month back and I have 8 months more for the entrance exam. Can I crack it? Yes, you can definitely crack it, Joshua. Just watch my strategy video for JEE 2022 students. What you need to do is go on YouTube and search for Shreyas Sir JEE 2022 strategy. I've given a detailed plan which chapters you should study when and how to study 11th with 12th, cover your backlogs and how you should study, make notes, etc. Every detailed thing is mentioned in the chapter. It's a big lecture. I can't tell you in 1 minute. All right, do that. No, they are not parallel. Okay. Yes, there will be. Sai Charan, they are not in parallel, bacha. Who told you they are in parallel? These 2 ohm and 6 ohm and this 1.5, these both are in series. These both are in series. This entire thing with this 3 ohm, they are in parallel. So this whole thing and this 3 ohm, they both are in parallel. Understand that. Okay. Be careful. So it is fine. It's correct. Alright. This session is for 12th. This session is for 12th batch, not for 11th. Alright. Let's move on to Kirchhoff's current law and voltage. I hope now Joshua and others, sorry, not Joshua, who is that? Sai Charan, you got it now. Okay. Now Kirchhoff's current law. Alright. Kirchhoff's current law, what is it based on? It's based on conservation of charge. Current coming in will be current going out. This is applicable for junctions, nodes, points where wires are intersecting. So if currents come in and currents go out, the sum of the currents coming in is equal to the sum of currents going out. This is useful for reducing the number of variables or to make equations, okay, for finding out currents or voltages in a given complex circuit. Sometimes, it is not possible to, condense it to a simple series or parallel circuit. Those times you need to make use of Kirchhoff's current law and Kirchhoff's voltage law. So what is Kirchhoff's voltage law? In Kirchhoff's voltage law, you take a complex circuit and in that circuit choose a starting and the ending point and then cover that entire circuit, okay, or maybe a part of that circuit, via some path. Maybe it's a complex circuit. There might be hundreds of things. You start from a point and end at a point. You come back to the same point. You will see that if you add the voltage difference across every device, voltage difference across this device plus this device plus this device plus this device, and when you come back to the same point, obviously the total voltage difference will be 0. I hope that makes sense. Yes. So if you start from one point, let's say A, and you end at the same point, then you will see the sum of all the voltages difference across all the devices will be 0. As simple as that. There is nothing great about it. And it makes sense because if you come back to the same point, voltage between that point and that point will be 0. But if you start from here and you go till here only, okay, so then it will look something like this. Voltage at point A plus voltage between AB plus voltage between BC, that will be giving you voltage at point C. So at point A I had some volts, I had some difference between A and B, I had some more difference between B and C. Whatever is the sum of their differences plus the initial voltage will give me the final voltage at that final destination. This is not a complete loop law, but this is an incomplete loop law. Okay, so this is also Kirchhoff's voltage law, but it's incomplete because I have not returned back to the same point. So you can use that. Yeah, I hope this is clear. Now remember one simple logic. Whenever you have resistors, the voltage drops in the direction of the current. So if this is the resistor and the current is this way, then this will be high voltage and this will be low voltage. So if you have this resistor, current is moving like this is high and this is low. Why is this important? because while you're traveling in a loop, okay, while you're traveling in a loop and you encounter a resistance, whether you should add the voltage difference or whether you should subtract depends on how you are traveling and how the current is moving. For example, let's say somebody is going from A to B. Okay, this is the path in which you are going. Obviously, this is high voltage, this is low voltage. So you are going from high to low, that means voltage is dropping. So when you are writing that plus minus terms, this term over here will be minus I1 R1. Okay, when you are going across this path, it will be negative because the voltage is dropping. Remember that. But if you are going from B to A, if the path was like this, then it will be plus I1 R1 because you are going from low to high voltage. That's something which you should keep in mind. For batteries, it's very simple. You don't take into account what is the current. Just check whether you are going from negative to positive or positive to negative. For example, if somebody is traveling from this point to this point in a big loop, if this was the path, then you are going from low to high. So the term that you will be using is plus E. If you are going from this point to this point, high to low, then you will be using minus E. Is that clear? Let's do some questions so that you will get a hang of it. All right. Okay. Chalo. Okay. Here is the question coming up on your screen and let's try to solve this. Let's see if you can solve this in a minute. There is a circuit which is shown. R1 and R2 are the resistors. Neglect internal resistance and the wire. The magnitude of the EMF E1, this value, such that the current through this resistor is 0. So what will be the value of E1 so that there is no current through R? Very interesting question. Let's see if we can solve this in a minute. All right. Advait, if you want the difference between potential and potential difference, here is what I'll tell you. Potential is awqat, capability. Does this point have capability? That means does it have potential? Some other point might also have some capability, so it also has potential. But both these points might have different awqat, different capabilities. So that difference is called as potential difference. That's it. Yeah. All right. Let's get moving, guys. Come on, my warriors. Can you name all the important chapters of 11th? Sarvesh, all chapters are important. If somebody is telling you these chapters are important, these chapters are not, then they are fooling you. Mast chuna lagaya. You will definitely fail. Guarantee. Likh ke de raha hu in JEE Mains. So there are important chapters, or rather I would say high priority chapters which can be related to 12 chapters. That's something which you can know, and that has been given in my strategy session. Just search on YouTube Shreyas Sir JEE 2022 strategy and check out all the 11th standard chapters which you can study with 12th and which chapters you should study after completing these chapters. Do check that out. That will be helpful. All right, cool. Let's see how many of you have got that correct. Now first of all, let me show over here that here the current is 0. That means here also the current is 0. The only current will flow in this branch. So it will flow like this, it will flow like this, it will flow like this, it will flow like this. Let's say it is I, some I. Now let me start from this point and let me go across this loop. Okay, this one which I have shaded. So if I apply Kirchhoff's voltage loop law in that particular loop, what I will say is I'm going in the direction of current high to low. Drop. How much is the drop? Minus I R1. From here it is I'm going from low to high, negative to positive, so plus E1. Here there is nothing. Again I'm going in the current direction, high voltage to low voltage. Current in the resistor goes from high to low, keep that in mind. So minus I R2. And I'm back to my original point, so it should be 0. Rearranging this, you will get E1 is equal to I R1 plus I R2. Therefore, you will get I is equal to E1 divided by R1 plus R2. That's of no use till as of now, but let's do something more. What if I apply another Kirchhoff's voltage loop law, but for the outermost branch? for the outermost branch. Okay, I hope you can see this, the outermost branch. And let's see what do we get. Okay, let's say we again apply Kirchhoff's voltage loop law. Let's say I start from here. Start. Battery is there, so plus E, low to high. Nothing is over here. Only one resistor going in the direction of current, so voltage will drop by how much? I into R2. Again over here, but this resistor will not have any voltage drop. Keep this in mind because there is no current as per the question. So I will put 0, or even if you put IR, I itself is 0 in that branch, so put 0 is equal to 0. Therefore, E is equal to I R2, but I is this value, so E1 divided by R1 plus R2 and into R2. So that's E. So therefore, E1, okay, E1 will be E into R1 plus R2, the whole thing divided by R2. So that should be option C, I believe. Yep. Some of you guys got it, some of you didn't. Very good, Zayed, proud of you. Yes, Zayed, your messages are visible. Very good. Some of you got it wrong, some of you said B. Don't worry, you might probably made a small silly mistake out there. Okay. Yes. Sukhdev, do this top 5 chapters from physics. IIT Pakka. For sure, Pakka. Okay, ठीक है. कच्चा पक्का हो जाएगा, वो पक्का कच्चा हो जाएगा. ठीक है. So if it was so easy, just do 5 chapters and clear IIT. I mean, I wouldn't be teaching on YouTube. I mean, just 5 chapters, right? Okay, just make those videos. Everybody, every day in, day out, I would make that student listen to it like a music. I would make headphones and I would sell those headphones. Yeah, listen to this chapter. But I had all these problems. Khatam, IIT Pakka, clear. Very good. So, alright. So, E R1 plus R2 divided by R2. Yes, that's the answer. Next question coming up on your screen. Hello, Chitra. How can a 10th student prepare for JEE? Advait, very simple. Attend the classes of 11th and 12th. Start reading from H.C. Verma. Start solving basic questions. Try to cover 11th and 12th syllabus, whichever you find it comfortable. Don't make a hard and fast rule. I have to complete 11th standard. No, just do whatever you feel like. I mean, whichever you are comfortable with. If you are comfortable with 12th, do 12th portion. If you are comfortable with 11th portion, do 11th. But 11th portion is must for many topics of 12th. So that's why you should at least do mechanics and then go to some 12th standard topics. From 8th standard, Chitra, how to prepare for JEE? Yaar, enjoy life now. Why do you want to study from 8th standard? Enjoy it. What is there in 8th? Study whatever is there in 8th. Why do you want to break your head and saturate yourself? See guys, honestly, 2 years of studies, maximum 3 years is enough. Okay, for studying for JEE. You don't have to start preparing right when you come out of your mother's womb. Okay, for JEE. You don't have to do that. 3 years maximum is good enough. 2 years is also good enough. Alright, cool. Let's get moving. Okay, EGL क्या करे? Subject ही ऐसा है. Alright, let's see how many of you have got this question. Alright, interesting. And what we have over here is, okay, let's apply Kirchhoff's voltage law and see. Okay, first let's assume the currents. Let's say the current over here is I. Currents from both of them come over here. So if this is I1, obviously this should be I minus I1. This is using Kirchhoff's current law. Sum of the currents in should be sum of the currents out. So if this is I, this is I1, obviously this should be I minus I1. So when you add these two numbers, you will be just left with I. Does that make sense? That's Kirchhoff's current law. Okay. My God, Chitra, let her enjoy, man. Girl, okay, chalo. Alright. Now, if this much is understood, this is nothing but Kirchhoff's current law. Everybody getting it till here? You can also do it by parallel combination of batteries, Abhishek, but I want to show you how to do it using KCL and KVL. Yep, NEET aspirant can also see this. Now, if this much, this is like basic. I mean, even if you give this question to 8th standard student, you will understand. I mean, he will tell, Acha, this is 3 amperes, this is 5 amperes. So this will be 5 minus 3, that will be 2 amperes. So if this is X, this is Y, obviously that will be X minus Y and all that. Okay, Very good. Now let's move ahead. Let's apply Kirchhoff's voltage law to one loop. Let's apply Kirchhoff's voltage law to this loop. Okay, I hope you can see this highlighted loop, and let's see what do we get. So using Kirchhoff's voltage law, starting from here, oh, keep in mind there is a resistance inside, internal. So starting from here, I'll get plus 12 because low to high, minus the voltage drop across the internal resistance, which is I1 into R. R is nothing but 2, and over here that's again minus I into 5, that's 0. Rearrange it. So 12 is equal to 2I1 plus 5I. That's equation number 1. Now what I can do, I can take one more loop, maybe this one over here. Okay, I hope we can see this. So how about taking this loop and going across it once. So again, if I use Kirchhoff's voltage law, let's say I start from this point. There is a battery going from low to high, so plus 12 minus IR, resistance will create a drop. I is, be careful, I minus I1, that's the assumed current into resistance, minus this current into this resistance, matlab I into 5. This is equal to 0. Fair enough. Let's rearrange it. 12 is equal to 2 into I minus I1 plus 5I. So therefore 12 is equal to 2I plus 5I, that's 7I minus 2I1. That's equation number 2. Now what should be the next step? Obviously take this equation 1 and 2 and add them. You can see that. So add first equation and the second equation, and let's see what do we get. 12 plus 12, that's 24. Okay. 7I and 5I, that's 12I. 2I1 and 2I1 gets cancelled out. So what is current? That's 2 amperes. So where is 2 amperes? That's option A, and that's it. Very good. Very good. Excellent A. Proud of you, my warriors. Okay. Thank you, Amina, Azian. Thank you. Do you think I will like 11th and 12th physics also? Advait, if you love physics, you will love any physics. Okay. Okay. Chalo. All right. Let's get moving. By the way, there is another way of solving this, and that is using equivalent batteries. For the hint I have given, try to do it at home using equivalent battery method. You might be wondering, so what's the formula for that? Well, you need to check it out in my playlist. That hard work you need to do. Everything can't be just given to you in the plate. So please check it out. How to find equivalent batteries. Let's move to electrical instruments, namely, ammeter, voltmeter, and potentiometer. You can go back, Amina. I mean, in case you want to start it from the beginning, definitely it will be better, but hardly few problems are left. So you can watch this, and probably whichever parts you find it difficult, definitely you can watch it from the start, or better, watch it in detail from the Pathfinder series. Okay, chalo. Let's get moving to the next one. Now, Venkata Narasimha Raju Varipeda, I am not understanding your name, bacha. Alright, chalo, let's get moving to the next question coming up. But before that, let's see the theory for ammeter, voltmeter, and potentiometer. Now, what is an ammeter? Ammeter is a device to measure the current. Now, how will you measure the current? Let's say there is a bulb. Okay, there is a bulb, and there is something, maybe there is a complex circuit, there is a battery and all of that. You want to measure the current passing through the bulb. What you need to do? You have to put an ammeter. How will you put it? In series. So that's the ammeter. Now the moment you put the ammeter itself will have some resistance. The moment that has some resistance, the current in the circuit will change. The moment the resistance changes, obviously the current will change. What you are measuring will be different than what it would have been before placing the ammeter. So when you place the ammeter, it should not disturb the current flowing in the circuit. That means the current flowing should be similar. That means the ammeter should have very, very low resistance. Very, very low resistance. Keep this in mind. Yep, very, very low resistance. So that low resistance will help it make sure that the current in the circuit does not change. So remember, ammeters have very less resistance, but an ideal ammeter will have zero resistance. EGL, Sriram, what do you think? IT is not halwa, no? You will not understand it like this. For that, you need to practice. You cannot just come last moment and say, sir, I'm not understanding, sir. You have to start from the beginning. You cannot come randomly somewhere and say, sir, I'm not understanding. Start from the beginning. Have you watched the previous lectures? This is a revision class. So make an effort, put effort from your side. Only then you will try and understand it. If you just say, sir is going to teach everything, I'm just going to sit idly and I'm going to understand, definitely it's not going to work. Okay. Even if Einstein comes and teaches, nobody will understand them. All right. Now the next thing is, how do you make an ammeter? You make the use of a galvanometer to make an ammeter. Now you'll be like, sir, what's a galvanometer? Galvanometer is also an ammeter, but of a very small range. It can measure currents only till few microamperes or picoamperes. So what happens is that, whenever you pass current through a galvanometer, then the needle deflects according to the current. So that deflection in the needle is directly proportional to the current in that galvanometer. So more the current, more the deflection, and that's how you measure current through a galvanometer. Galvanometer is nothing but a device. It has got a needle, it has got a scale. Depending on how much current you pass, it will deflect. But that also has a limit, because the needle can only go till certain extent. Beyond that, it can't move. So there is a limit till which the galvanometer can measure the current. That's called as a full scale deflection current or maximum current through the galvanometer. Now, if you were to use this galvanometer in the circuit, the problem is that current will be so much that the galvanometer will be burnt out. So you want to avoid that. So imagine you have a circuit, maybe this is the branch, and you want to measure the current through this branch. You want to measure how much this I is. If you just put a galvanometer, gone, it's going to burn out, because galvanometer has very less capacity to handle current. So what will happen is, this galvanometer can be arranged like this. You connect another resistor in parallel like this. You connect another resistor in parallel like this, and make sure very little current passes through the galvanometer. Most of the current will get bypassed across this resistor called as the shunt resistance. Now, when that big current passes, very little current will pass through the galvanometer. Most of the current is made to pass through the parallel resistance, and now the galvanometer won't get burnt and it will still deflect and it will show you the reading. That's nothing but an ammeter. So a galvanometer with a resistor in parallel is called as an ammeter. I hope this is clear. Yes, I hope this is clear. Shunt means parallel, nothing else. So shunt means parallel, nothing else. Okay, so it's a parallel resistance. Now, once you understand this, okay, this is the same diagram. You don't have to by heart all these formulas. Just remember one thing. Whenever you see ammeter problem, just think inside an ammeter there will be probably one more resistor in parallel, and somehow I have to bypass that current so that the galvanometer does not get burnt. Now, if you solve this problem like a normal series parallel problem, your job is very easy. If you by heart this formula, trust me, it will be very difficult. All right, Venkata, nice pet name. That would be very easy for me to call you. All right. Now, here is what happens. This current will get divided into these two branches, current through this galvanometer, current through this shunt, and this ratio will be inversely proportional to the resistances. This is the resistance of just galvanometer, this is the resistance of the shunt. So you can just say IS by IG will be RG by RS. Keep this in mind. So that's something which you should keep in mind. This is inversely proportional. So you just solve it like a normal series and parallel circuit. Nothing great. Yep. No, Avinash, it's not that great. if you take it right from the start till the end. It's okay, I mean it's not bad, but just that book will not help you. Now, voltmeter. Whenever the symbol of galvanometer is G, yes, but symbol of ammeter is A. So A is nothing but G plus a resistor in parallel. So A is G plus some parallel resistance, which you call it as a shunt resistance. That's what ammeter is. Now, what is a voltmeter? Again, I have discussed this in detail. This is a revision session. Please understand that I have spent 1.5 hours previously detailed discussion on this voltmeter, ammeter and potentiometer. You can watch that as well. But still, quickly revising. Whenever you have a lot of devices and you want to measure the voltage across this, then if you want to measure the voltage across these 2 points, you connect a voltmeter in parallel. Voltmeters are always connected in parallel. Ammeter is connected in series. Keep this in mind. Now, when you connect a voltmeter in parallel, you obviously do not want the current which is flowing through this circuit to pass through here, because if it does, then all the current will flow through the voltmeter and then this device will stop working. So you don't want that. So what is done? That's why whenever you have some device and you want to measure the voltage across it, you need to make sure that this voltmeter has very high resistance. So then the current flowing through it will be very, very minute. Yes. Now what happens inside a voltmeter? A voltmeter is nothing but a galvanometer plus a very high resistance in series. A very high resistance. Voltmeter has very high resistance. So how do you increase the resistance? By attaching a very big resistor in series. And whatever voltage will be there across these 2 points is the voltage which will be, okay, because remember this and this are in parallel, right? So the voltage across the device is also the voltage across galvanometer and resistor in series together. These two are in series. So guys, what is the total voltage? It is the voltage across the galvanometer plus the voltage across the series resistance. What is the voltage across galvanometer? It's current through the galvanometer into resistance of galvanometer. What is the voltage across resistor in series? It's current in the galvanometer into resistor in series. So take out Ig common. Won't you get this? This is exactly what you get. So my point is, whenever you see voltmeter and ammeter problem, do not think and memorize this formula and try to recollect it. Solve it like a series parallel problem. That's it. You should know what is ammeter. Ammeter is galvanometer plus resistor in parallel, but they are connected in series to the circuit. Voltmeter is nothing but galvanometer plus series resistor connected in parallel across the device. That's it. I hope this is clear. Yep, that's all. Correct time now. That's a perfect summary of whatever we have studied till now. Last thing before we go ahead. Okay. Yes, you can definitely prepare for IS when you are studying for BTech. Definitely. Potentiometer. Now, what is this potentiometer? This is also another device. It can be used to measure internal resistance of a battery. It can be used to compare the EMFs. It can be also used to measure the voltage between any 2 points. Now, how to do that? Well, see, what you have are 2 circuits. This circuit below is usually called as the primary circuit. There is this shaded wire, this orange yellowish shaded wire, that is called as the potentiometer wire. It has very high resistance, and keep this in mind, resistance is directly proportional to the length. Whatever, depending on the length, the resistance is proportional. There is a battery connected. You can change the resistance from here. There is a switch and all of that. There is a circuit. This is called as your secondary circuit. This is your secondary circuit. Some complex circuit is there. I want to measure voltage between this point and this point. Usually you can use a voltmeter, but this potentiometer can also do the same job. How? Very simple. What you need to do is connect this point to this point, one end of the potentiometer. Okay. Now when you do that, don't you see this point and this point will have the same potential, Think about it. This point and this point will have the same potential. Everybody agrees? Fair enough. Take another point where you want to measure the potential difference from. Via a galvanometer, connect it to a contact point on the potentiometer wire. Connect the galvanometer via contact point, that is usually called as a jockey. So that jockey is a movable sliding contact on that potentiometer wire. Now you can move it, and I'll tell you what has exactly happened on this potentiometer wire. When this battery supplies the current, there will be a voltage difference across A and B. Example, let's say this is 10 volts. Example. So this will be also 10 volts. So you will see somewhere over here 9 volts, somewhere over here 8 volts, so on and so forth. Maybe somewhere over here, maybe this is 4 volts, maybe this is 5 volts, this is 6 volts. Okay, oh sorry, my bad. This is 3 volts, so on and so forth. This is 2 volts, this is 1 volt, and this is 0 volt. Okay, this is back to 0 volts. Ignore that resistance for now. Let's ignore this. Okay, just ignore this for now. Do you see there is a potential gradient which is set up? Now, for example, you know, the actual voltage between these 2 points, example, okay, is let's say 6 volts. 6 volts. Then, when this point is connected here, this point is connected here, check what is the difference between these 2 points. Voltage difference between these 2 points, 10 minus 4. What is the difference, guys? 6. Correct? It is 6. Everybody clear? Thank you. Thank you, Jiva. Now, also think, if there is no current in the galvanometer, that means there is no voltage difference between these 2 points. If somehow this J is at such a point that galvanometer does not allow any current, or no current is flowing through the galvanometer, it is at 0, then these 2 points are at the same potential. And anyways, this is a wire, so these 2 points are at the same potential. So whatever is the voltage here will be the voltage here. So if the actual voltage was 6, then no current will flow through this circuit if you put this point at 4 volts. So the current through the galvanometer will be 0. This is called as a null point. What is it called, guys? It is called as the null point. Keep this in mind. Why null point? Because there is no deflection. If suppose, okay, let's say I make this contact point touch here, then what will happen? The actual voltage is 6, but you are making the potential difference 10 minus 3, which is 7 volts. That's a problem. So think about it. The actual point over here is 3 volts, okay, and the difference is 7 volts. But here the difference is 6 volts. So obviously current will flow over here. So that means, yes, so that means, you know, that will not be a null point. So you move the slider till such a point where you get null deflection. Yes. I hope this is clear. What can we say if no null point is obtained on the potentiometer wire? Well, there can be different reasons for that. Maybe you have connected in the wrong way. Remember, this is always high voltage and this is low voltage. So if you connect it like this, so if I go here, there should be a drop. But here also there is a drop. Imagine I connected low voltage here and high voltage here. Then I will never get a drop. So that means I will never get a null point. That's what it is. I hope this is clear. Everyone clear? Jai, Ajinkya, I hope this makes sense. Now, whenever, understand, a circuit which has certain voltage difference, maybe it could be anything, let's say V or delta V. Whenever null point is obtained, so at null point, what will happen? The voltage difference between these 2 points is also the voltage difference between A and J. It's also the voltage difference between A and J. Keep this in mind. Now once you get this, it's becoming very, very simple. Why? The voltage across these 2 points, can be thought of as, think about it as if there is one resistor here till J and another resistor here till B. So voltage across one resistor, when two resistors are in series, how much it is? Everybody knows this. Everybody knows this. If I have two resistors in series, voltage across any one of those resistors, how much is it? It's the resistance of that particular resistance, which is AJ, upon the total resistance, which is AB. Any one resistance upon total resistance into total voltage. What is the total voltage? Let's say it is E. Total voltage is E. Everybody getting it? Now that's the simple thing. Remember, resistance is proportional to the length. Oh, how much ever is the resistance is proportional to the length of that wire. So ratio of the resistance will be ratio of the length. So length of AJ upon length of AB into E. So that will give you the voltage difference. So remember, this is the length of the total wire. This is the length of the total wire A to B. This length is also called as the balancing length. Balancing length. That's how you solve the question. I hope this is clear. Yes. Very good. Very good. If you guys have understood it. Excellent day. Some of you are trying to control the chat. Very good. Proud of you. Yes. So that's the logic for solving the questions. So if you remember the theory properly, if I understood the concept, that's it. The voltage difference between these 2 points at balancing condition is the voltage between these 2 points. Voltage across these 2 points will be as if two resistors are in series. Oh, the voltage across any one resistor in series is resistance upon total resistance into total voltage. That's it. Gone. Done. Very simple. Very good. So keep this in mind. Now I think we have very little time left, but we'll try to cover up as many questions as possible. Okay, here is the first question. If there are some questions remaining, I'll probably give it to you as homework. Okay, the circuit shown here is used to compare the EMFs. This is the wire. The above part is primary. Okay, first time I'm connecting this battery. Second time I move the switch and connecting this battery. Every time I'll get different lengths. So first time when E1 is connected, I'm getting this point C. If I now switch it to E2, this point, balancing point, will shift towards left, right, or it will not change, or it will not be there itself. What do you guys think? Welcome Amu. Come on, bacha log. Think. What do you think will happen? All right. First, imagine this is length 1. Okay, this is length L1. This is the balancing length. Everybody agrees? Okay. I just gave the formula. This is my external circuit. What is the voltage difference? What is the voltage difference between these 2 points which are connected between A and C? That delta V, I had just told you, it is balancing length upon total length into that voltage of the primary. Now if you use this logic, you will see E1, which is the voltage difference between these 2 points, is L1 divided by L into that primary voltage, which is just V. You can see that. Now when you change the position to switch to, what will you get? E2 will be new length divided by L into V. According to the question, E1 is more. E1 is more. So this ratio will be more. So hence L1 will be more than L2. So if L1 is more than L2 or L2 is less than L1, what does it mean? When you change the switch position, over here, this balancing length will be somewhere here. So this will be the new length L2. So it will shift towards the left side. So hence the answer is A. Very good Vaishnavi, very good knowledge facts. Okay, finally you got it. Hello Sahil, ITZ. Okay, what are the applications of potentiometer? Well, like I said, it's to compare EMFs. Like you can see, you can compare EMFs. You can also measure the voltage across any points Like it can function like a voltmeter also. So that's the application of a potentiometer. It can be also used to measure internal resistance as well. All right, yep, A is correct. Okay, I hope that is clear, Venkata. All right, let's get moving to the next one. Let's see if we can get this beautiful question again on potentiometer, guys. Come on, my warriors. AB is a potentiometer wire. If the value of, oh, this resistance is increased, then in which direction do you think this balancing point will shift? Completely conceptual question. Let's see how many of you can figure this. If I increase the resistance, how will this point, balancing length, be affected? Assuming the outside secondary circuit is still the same. Interesting question, right? Okay. Let's take some example. Imagine initially resistance was very less. Just imagine initially. So initially, okay, imagine that variable resistance is negligible, 0. Okay, just imagine. Okay. So if this is E, this will be 0. Okay, let's say this is 10 volts. This will be also 10 volts. Maybe let's say this is 5 volts. This is 0. This will be 0. This will be also 0. This is how it will look like initially. So that means this EMF is basically 5 volts. Okay, just assuming. Just assume, take some numbers to get a feel. Remember, it's all about feel now. So this EMF is 5 volts. So that's why the voltage difference is 5 volts, like you can see between A and J. Clear? Okay. That's when the balancing length will happen. No current will flow because this voltage and this voltage is same. No need for current to flow. Okay. Now, here is the next thing. Eventually, finally, when the resistance is increasing, okay, maybe something more than 0. Now things will change. If this is 0, there will be some voltage difference between these 2 points. Maybe, I'm just saying, maybe it is 2 volts. This is 0, this will still be 10. If this is 10, this is still 10. If this is 2, this is 2. Now comes the challenging part. Think about it. What is the voltage difference between A and B now? It is 8 volts. Earlier, look at the green numbers, it was 10. Voltage difference has reduced. Okay, keep this in mind. But this outside circuit is still the same. So I should still get 5 volts. So where will I get 5 volts? Think about it. Where will I get 5 volts? Will I still get it at the same point? Obviously not. Because 5 volts earlier was exactly at the center. Example. Now, exactly at the center, you will have 2 and 10's average, which is how much? 6 volts. So at the same point, if you stay, you will get 6 volts. Understand this. Now the difference between 10 and 6 is just 4 volts, guys. But you want 5 volt difference. So where will you move this? If you move it somewhere here, then you will get 5 volts and then the difference will be 5. Hence, you are going to move it towards B. Hence, option A is correct. Is that understood? What a beautiful logic out here. Excellent problem this is. Okay. Excellent. Very good. Very good. So that's how you solve these questions, guys. We are very short of time, but you can solve this question as homework. Okay. And I will probably stand in front of it so that you guys don't see the answer. And you can also solve this question as homework. Please post it up in the comment section after the video ends. I'll be really happy to see all your answers out there. Okay, I'll again stand in front of it so that you do not see what is the correct answer. All right. So if you want to take my batches and if you want guarantee that you are going to improve, that's VIP, Vedantu Improvement Promise, wherein we guarantee that you will improve, and if you don't, the money is returned back. So check out the Vedantu Pro subscription, where my micro courses and other teacher micro courses, plus the option for you guys to learn in English as well as Hindi, the long-term batches, KVPY batches, all for free. Everything, whatever you need for JEE Mains, Advanced, BITSAT, KVPY and any other exams is covered under one roof at no extra cost. Assignments, test series, booklets, hard copies, doubt solving, personal mentorship, strategy sessions, you name it, guys, everything sitting at home. What more you want? Obviously with the best teachers, in the country. You don't have to travel anywhere. And if you want doubt solving on the mobile app, you go for the classic version, and the plus version will give you the additional benefit of personal mentor. Now, if you want to know more about this, there is a link in the description box. Check it out. You can also use my coupon code, which is SHHPRO, which will give you 10% off. So that's 3,000 rupees roughly per month. That's very affordable. I mean, compared to the lakhs and lakhs of fees charged by different offline coaching institutes, which don't give you half the things shown on the screen. So check it out, guys, and make sure you take this offer of 10%, because the batches are going to start on Monday. So I'm pretty sure you don't want to miss it. And the more you delay, the more likely it is that you will have to cover up the portion in a hurry. So the better it is you start it aram se and take up all these courses and study in a very peaceful manner rather than taking it up as a crash. All right, thank you guys for being here. Glad Srinath you loved the session. Thank you Jeeva Vacha. Shukriya, says Vijay Kumar. And what is my opinion about the NEET 2021 paper? I'm guessing it will be easy, and most of it will be from NCERT or something what is there in the NTA question bank, and very similar to JEE Mains or even simpler than that. All right, yes, thank you. Welcome Pradeep. Bye bye, take care, and all the best for your JEE results, the 4th attempt, Bindu, and all the others as well. Vaishnavi, welcome. All right, so in the mechanics part, if you want to make it perfect till JEE Mains level, then please watch Ritvika, all my mechanics videos. It's already there, bacha. Do that. Take up my micro course, HC Verma, a short answer that will clear all your concepts. It's all there. Also take up my numerical micro course for mechanics. It's all there. Irodo problem solving. It's there for free of cost once you are a pro student. Please take it up, okay? Because I have taught it over there. Okay, knowledge facts, nobody knows when the results are going to come out. Oh my god, Vijay Kumar, I don't understand it. Okay, good night EGL. Bye bye Jai Ajinkya. Take care Jeeva. Thank you guys for all the love. Anything about JEE Advanced 2021, Anshul, please watch my sessions and all the sessions conducted on this channel for JEE Advanced. They are very top-notch problems. You can check it out. Today morning also I conducted one mechanics session, before that PYQ session. So continue watching our Mission IIT series that will help you, motivate you, and stay in touch with good level problems for JEE Advanced. Okay, so do that. All right. Bye bye champion. Take care. Hasta la vista guys. This was Shreyas here.